Let's look at creating a linear function where we're looking at current salary S after X years of employment. They start their job with a salary of $50,000 and they can get an annual increase or raise of $1,200. We're going to write this equation and keep in mind that they're going to retire after 40 years of service, so they're not going to be working 90 years on the job or anything like that. Thinking about linear functions, we are thinking about y equals mx plus b. M is the slope, and b is the initial amount or y-intercept. So for this function, I'm just going to start it with y equals mx plus b. We'll switch to s and x in a second. We're going to figure out which one of these is a slope and which one is the y-intercept or the initial amount. So their starting salary is $50,000 and they have an increase of $1,200 per year that they work. So our initial amount is $50,000 plus their slope would be 1,200 times X number of years. Or you can write it the other way around. We want to make sure you switch this with an S. Their salary is going to start at $50,000 and increase, so positive slope of $1,200 per year times X years. So just switching to the correct variables. We're going to think about the domain. Domain is X values. It's left to right. We want to think about X values, and this one stands for years of employment. So like I said, they're not going to be working 90 years. It says they're going to retire after 40 years of service. So we want to think about what's the least amount of years you could work for a company. Well, the smallest amount you could work for a company is 0. You just walk in day 1. You've worked there 0 years. And the most they could work is 40 years. So we're looking from 0 to 40. Could you work 0 years for a company? Yes. When you start out, you're at 0 years. And can they work up to 40 years? Yeah, they could work that 40th year. So we're going to do square brackets. We're going to include our endpoints. We want to figure out what would the range be for this function. Range is y values. It's normally read down to up graphically. For these, the y value is S, which is the amount of money they're getting for their salary. So I'm going to figure out what's the least amount they could make and what's the most amount they could make. Well, starting out in year 0, they are offered $50,000. So that's going to be their lowest income earning year, is at $50,000. But they're getting a $1,200 raise, and if they stay for 40 years, that's going to tell us the most amount they would make. So we're going to find the salary for 40 years is going to be $50,000 plus 1,200 times 40. Which will give us 98,000. So they'll make 50,000 year 0, and year 40 they'll make 98,000. I'm going to figure out what would their employee salary be after 15 years. To figure that out, we're just going to plug in X as 15. So we have the salary after 15 years would be 50,000 plus they've gotten a $1,200 raise for 15 years. So we know after 40 years, they're going to max out at 98,000, which if their goal is to make 6 figures, they want to make over 100,000. This is not a job for them to stay at. After 40 years, they're only at 98,000. But they might say, well, I'll stay here and get a bunch of experience and then move from there. So let's say we're going to stay 15 years and just see what our salary would be. We know it's going to be somewhere between 50,000 and 98,000. It looks like after 15 years, they're at $68,000. Make sure you label each Y value. So not a bad salary, but maybe by then they have enough experience to try to jump to another company that offers some bigger compensation. The last part says here, well, say they really do want to break that 6 figures. They want to make $105,000. We know that's not happening in their first 40 years of working because they are getting to 98,000. But how long would it take? So we're going to set 105,000 as our salary. Initially, they earn $50,000 plus they're getting $1,200 raises times X years. So to solve for x, I'm going to start by subtracting 50,000 from both sides to try to get the x by itself. So we're looking at a $55,000 raise. And we need to have that equal to 1200x. We're going to divide both sides by 1200 to figure out how many x years we need. So to get x by itself, we do 55,000 divided by 1200, and it's going to take 45.83 repeating years. So over that 40 years where they're supposed to be retired, it would take 45 years to be making that 105,000. So we're going to think about most of these problems. We would typically be given a year. So if they started this job in 1990, let's say, what year would they earn that 105,000? Would be plus 45.8 years from 1990. So we'll take 1990 plus 45. If it said in which year does this happen, it would be in year 2035. Just to prepare us, we're going to be asked in which year does things happen. So if they started this job in 1990, the year in which they would make 105,000 would be 2035, because it'd be 45.8 years later. So it'd be later in the year in 2035.